Let's start for this afternoon after a perfect lunch break. Thank you for the organization for providing a fine meal for everybody. We appreciate it. The first talk in this afternoon in this room will be about Relax and Recover. That's concerning disaster recovery for Linux environments. And we will try to explain it how make life easier for you. But before we dig in, let's first start about myself a little word. My name is Gratien. I'm from Belgium, from Antwerp, so it's not that far away. I'm already very long time busy with Unix. I used to call me a senior consultant, but as I'm a senior now, just call me an expert consultant. That's for fun. I'm already involved in a very long time with Unix and with Linux projects, also with the Belgian Unix users group in the time. And have some open source projects. The most known is probably Relax and Recover, but I'm also involved in others. They are listed here. Maybe config2html is ringing a bell. I'm the co-developer for Linux now and also for the main track for HPX. Some other projects. They're all on my GitHub and my home pages. Okay, before we dig into disaster recovery itself, let's put the picture right. Business continuity is about how to restore your business as soon as possible when a disaster is occurring. Disaster recovery or a recovery plan is only a part of the whole picture. As you can see here, there are four main domains in business continuity. And where we focus today is only a part of it, the recovery plan. And there fits Relax and Recover. Okay. I have another talk, especially about business continuity, but I already gave that, not here, but somewhere else. That explains the complete business continuity plans and all the steps how to make a good plan. But okay, recovery plans. First of all, I hope you all have one, big one, small one, at least something. These things is maybe funny on a picture, but in real life it's a real drama. So be prepared and do something about it. A recovery plan for your technical equipment are four domains which are important. It's about the uptime. You want your equipment as soon as possible up again. It's about the trustworthy. If you do a recovery of a system, you have to rely on it that it's working, but at least that your computer is back online as soon as possible and not half broken and that you still have to do 100 steps manually. So you have to train it. And that's the key word about it. And the cost. It has to be affordable. As we are in the open source world, there are some open source packages available to make your Linux disaster recovery possible. Relax and Recover is one of them, and the other that's also very famous is the mkrescue. I forgot to mention, before I started with Relax and Recover, I had another project called mkrescue recovery, which was also a Linux disaster recovery project. But together with a German colleague, Shlomo Shapiro, we rewrote it from scratch, and that was the birth of Relax and Recover in 2006. By the way, I think it only took us 5 weeks to make the first release of Relax and Recover. That's because we took the best of Shlomo's project, which was the framework, and we took the complete knowledge of mkrescue recovery, and that I wrote so I could easily make it happen. And I will explain it how it is becoming possible to add something to, and so on. The complexity, because I was fading away from the topics. We tend to make our plans too complex. As a rule of thumb, if you go away today, the KISS principle, keep it as simple as possible, is the key for success, at least for your computer environment. Business continuity is much more complex, but that's another topic. Keep it simple. And to make your life easier, we wrote Relax and Recover. The name, I chose the name because it should be to become a relaxed process, to recover in a relaxed way. That's why I chose Relax and Recover, and the acronym is REAR. It is a disaster recovery framework, and it uses workflows. We will see it a little bit later. The nice thing about REAR is it completely is written in Bash language. So it's written for system administrators, and you can easily add your own stuff in it. So you can extend it. Deploy is easy. Once you have tested it, you have the trust in it, you can just put it on your system, make your configuration file complete, and that's it. And you just put it in a cron. That's automatically done, by the way. If something changes on your file systems, on your kernel, automatically it will know that, and it will recreate an image, a disaster recovery image, and even a backup, if needed. It integrates in various Linux technologies. It does work on OpenSUSE, on SLES environment, on the Red Hat environment, on Ubuntu, and on much more Linux distributions. Another important thing is it has an internal integration of your backup using GNU tar or rsync, but it can easily be extended, or it is extended already, for open source backup solutions, BAREOS, Bacala, for example, or even commercial backup solutions. And the recovery system should be as easy as possible, of course. But the most important thing is, as other solutions, everything can be done online. So you can just run your REAR image, your backup solution, and your disaster recovery image creation online. And nobody will know it, in fact, because you can just schedule it. It will be done automatically if it's scheduled via cron. So that's a nice thing about it. So what is REAR? I already mentioned that there are developers in Germany, like Shlomo. There's also a new developer, Johannes Maxner. He's from SLES, from Lovell. He's very brand new. We wrote together the BetterFS implementation for SLES, in fact. Already said, it is Bash. We do know one limitation is the kernel 2.6, but as we are already beyond the 3, that doesn't matter anymore. It supports almost any kind of hardware solution, RAID, integrations, LVM, any kind of file system is almost supported. And the integration with network solutions like NFS, CIFS, can use rsync, USB, and boot media, DVDs, ISO images, can boot from USB storage and also from the LAN. And even bootable tapes, but who uses bootable tapes anymore? I don't know. But it still works, it's there. One button disaster recovery solution, everybody's heard something? Okay. Okay. Important thing is, REAR main focus is on disaster recovery, not on the backup, okay? There is an integration with the backup software. You have the possibility to have a full backup integration with GNU tar, rsync, or if you use an external backup solution, you don't care because your external backup solution will take care of the full backup. So you only focus then on the creation of the disaster recovery image itself. That's what we're saying here. I'll come back to that later. So REAR use the best tool for the job, disaster recovery. But before we start using REAR, you have to make some decisions. One of those decisions is, which backup mechanism will I use? Will I use the internal one? I must say 70% is using the internal one, but a lot of customers are using an external backup solution. And quite a lot of commercial one, like TSM, NetBackup, Date Protector, and some others. So you can use the internal or the external one. And then you have to decide where your backups will reside. One rule of thumb is, make sure that your backup archives are stored on a remote environment, a remote data center, remote disk, not in the same beside your computers, of course. Because if your computers are broke or fire or flooded, then you lose also the data. So keep that in mind. If the cloud storage is possible, with duplicity, that's also integrated. And the remote network storage, well, it's NFS, CIFS, The cloud storage, for example, is all possible. rsync is a possibility, so you can really use remote stuff. There's another one, this is secure self file system. Ever heard of that? It's SSFS. It works quite well. I use it quite a lot. It's a kind of cloud backup. So I use it to another smaller data center to make backups of smaller computers. Because you have to be aware, if you use the internet, then you can't have lots of terabytes over the internet because that's taking too long. The media. Already mentioned, external storage, quite important. Never keep your storage of your backup besides your computer, but somewhere else. And I already mentioned the boot media can be a CD, ISO image, can be over the network, USB, and you can have both effect. You can boot from an ISO image, but you can store your media or your backup media on an NFS share, CIFS share, or somewhere else. So you can really differentiate. That's all definable via the configuration files. How does it work? The first thing that REAR is doing is storing your disk layout, because the thing is, if you want to recreate your data, you need your file systems up and running first. So therefore you need the knowledge about your disk, the sizing of your disk, the sizing of your file systems, which kind of file systems, which are the characteristics of your file systems, etc., etc. Also the labels and also the bootloader is important, because if your system is not bootable, that's a bit of a problem. Store the files, that's through the various mechanisms that are available. It can be NFS, you can use tar, rsync, etc. Then you have to create your bootable rescue image. So it will copy, in fact, all the nice executables that it needs to recreate your computer after failure. So everything will be on one image. And it's all the executables, the libraries are from your live system. So there is no problem that it cannot work, because they're coming from the same source, in fact. So there is no problem with libraries and stuff like that. Already mentioned, everything is done online and it's 100% compatible. Well, if it's from the same source, that's logical. The rescue media, if it's an ISO image of a USB disk, doesn't matter. It contains all the executables that it need to recreate your file systems to make your system bootable. And even if you have an integration with an external backup solution, all the executables that the client needs to communicate with the backup server are also included. So that's the integration of the remote backup software is there. And of course, everything that the kernel needs, the device drivers, the network configuration, everything is there. You can, the boot image when it boots, you can have the same IP address as from the source. You can have in DHCP. You can define your own IP addresses. You can redefine it. There are several ways to make that happen. And everything is done in RAM, so in the initial RAM disk. So that means that the rescue image is running in RAM, and everything else, all your disks, is then free to use to make it, partition it, to mount your file systems, make the file systems, mount it, make it ready for the restoration of your data. So how it is done in practice? So you boot from the rescue image, it will restore your disks, so it will see which kind of disks are there. It will ask them if it's not 100% the same. It is an interactive menu that comes up then that will tell you, okay, this disk, do you want this disk? Yes, then okay, it will reformat it, create your partitions. Even the hardware rate can be reconfigured if needed. Create the file systems, make the file systems ready, label it if needed, and then when they are mounted, then they are ready for restore the backup data. Once that is done, restore the bootloader, reboot, and then it's finished. It's as simple as that. And that's what I mean with the relaxing part. It should be as simple, start the command, restore, REAR, restore, recover, and then after a few minutes, if it's a small image, in VM, for example, that's quite done. Within less than 2 minutes, you have your system back. Furthermore, this can also be used for migration. It is used from P2V, V2V, and V2P. There are customers who are using that for really migrating their data from physical systems to virtual systems. It really works. Some words on backup software already mentioned. This is the list of the external backup integrations which are already in place. Some of those were in fact sponsored. Sponsoring means that they hire me or some other consultant to do the integration, but it's all, once integrated, it stays in the software, and it's all open source, the integration part. This is the cloud duplicity. Some people already heard of it, of using it. It's a very nice, I like it. It's all encrypted, nice encrypted, and it goes over the, you can really use it in the cloud. And the integration works quite well. rsync is also one of my favorites, pure rsync, and then you have, of course, which a lot of customers are using is the tar combination with an S filer effect, and then they store a lot of gigabytes of data on the NAS. Okay. Other customers are preferring commercial solution because they already have that in place in the full backups, and then they only make the rescue image, put it then on the NAS, or even make the backup inside their commercial solution. And then if they wanted to just restore the ISO to another system, boot it, and then restore the complete system from the backup server. So extending this is very easy. Some people are doing themselves, and then they submit a pull request. We check it. Most of the times we need to do some tweaks and tricks about it because it's not always 100% correctly done. I must say, I already have written several of these integrations myself, and then other people correct me because when there's a new upgrade, sometimes a new library comes in. That's the nice thing about open software. It's a combination of several factors that people that are working together, and that's what I like. Even I make mistakes, of course. The network integration. That's a nice thing. If you have a very big data center with thousands of Linux systems, it is not always simple to make for every system an ISO image. So therefore, a lot of customers are using the network part, so booting over the network via PXE booting. That is, of course, possible. The philosophy and the methodology is exactly the same as via ISO. You just retrieve your initial RAM address from the network, you boot, and then you have, of course, probably the archives via NFS available. Maybe worth to mention, there is a new project written by 3 or 4 Spanish guys from Barcelona, or in the neighborhood of Barcelona. It's the Disaster Recovery Linux Manager. That's in fact a rear server that can have send pushes out to make a new image. And if you want to recover, you use the Disaster Recovery Linux Manager to make the initial request to start the recovery. That's all over the network, so that's a nice thing. And they're using the same framework as rear does to make that happen. So if you want to get started with rear, at least you need to be able to download it. As it is open source, we have a website. It's called Relax and Recover. You have stable and you have snapshots that are built daily. If there is a change, of course, it's automatically triggered. And the official sources are on GitHub, so you can just clone it and start your own rear development if you want it. And from there on, that's what I prefer. If you have some updates, you make your own clone, and then you can make a pull request and send it to the head of rear. And this is the head, of course. Rear is also a very long time integrated in some official repositories, like in the Fedora ones, and also in the SLES. By the way, in SLES it's already, I think from 2008, if I'm not mistaken, available as track of the high availability track of SLES. Albeit a bit behind. I'm working with Johannes Meixner to get the 1.17, which is still the latest release in the new HA So probably in the new service packet will be in there. So with the zipper install, you can just install it then. The installation is as easy as that. If you download the RPM, and you need, if you want to use the ISO Linux, sys Linux, but mostly that's already part. If you want to use NFS, you need some of the clients or CIFS clients, rsync. And open secure shell is, I think, that's standard in each distribution these days. Most of the times, if something is missing, you will get an error message in the rear, and then you see it in log files, and then you can install it, what is missing. Okay, to get going, the backup flows, if you're using the internal backup flow, then it's the NETFS is the mostly used. Or if you are using rsync, then you can say rsync. So it's backup equals NETFS, then it means you will be using NFS to store your archives somewhere. It doesn't say where. That is the backup URL that's shown in the next big slide. If you're using an external backup, then you just say backup, the one that you need, of course, and that's it, in fact. For that point, rear will say, if you're using an external backup mechanism, I don't care about your backups. I just care about making the rescue image, and that's it. Okay? So, if you're using an internal one, it will make a full backup. All right? And how that is done? That is through, first the output flow. Backup is about the storing the archives. Output is about storing the ISO image or the rescue image. It doesn't have to be an ISO image, of course. ISO, output can be to the ISO, USB, PXE, boot tape, or the RAM disk, just RAM disk. So you have two flows, for the backups and for your RAM disk effect. And for that, for example, for the internal backup solution through NETFS, you can say output ISO, but still it can be stored via NFS CIFS local. That's all part of the NETFS, or even in tape. If you say USB, output is USB, and backup is NETFS, that means that your USB disk will be prepared as a bootable USB disk, and the backup will be stored inside the USB disk. And you can have several Unix systems or Linux systems making part of it, so it's separated by directory structure. How can you differentiate NFS, CIFS, etc.? That is through the backup URL. That defines the location. Okay? The location, you can see it there on the right side. You say equals file means on the same system. NFS means an NFS location. You have CIFS, USB, tape, and ISO. The latest one, ISO, that means that you will create one big ISO file system, including the archives, backup archives. There are some customers still using that. Remember, I wrote initially, 50 years ago, make CD-ROM recovery, which was the purpose, making the complete backup and the bootable CD. And if you're using the last type, it's the same thing that happens. Still customers like that. If you want to use an external backup solution, then it's the similar philosophy happens. You define your output. Output means where do you want your rescue image? Do you want it on an ISO image, USB, network, even a tape? And backup means everything will be stored via the backup server. So you do not care, or RIR does not care about your backups anymore. Only about the rescue image. The local configuration file is at least one configuration file that you need to define. It's local.conf or site.conf. You have the choice, in fact. And by default, output is already ISO. But if you do not define an output URL, it will be just stored on the system itself under the var lib rear output. Therefore, it's always handy to define at least two variables. The backup, which kind of backup do you want, an internal one or an external one? NETFS is internal, then you have to define a backup URL and a remote location. That's very important. And the path is that first, after two slashes is the server and then the path. And on the LFS server is always stored under the path that you defined, and then it will create automatically a subdirectory with the host name of your Linux client. So that means if you do hundreds of these servers with the same URL definition, still there is a differentiation with the host name. It's always handy if you're starting with rear to do a rear dump, because then it will tell you which kind of system you have and what does it find of your system. Does it find configuration files? It will tell you the architecture, the version, and the rear has some help functionality embedded about the options. Very handy option is debugging, if you want to debug something. The simulation, I will tell you a little bit more about it a few moments later. Step by step, that means that each function or script will be asked to start. So if you want to debug something, but that's only for experts, and the verbose. And a capital V is the version. Then the workflows. Most of the times you're using or mkrescue, that only creates the rescue image. If you have an external backup, then there is no need to do run a make backup, because the make backup for an external backup is the same as mkrescue. If you're using internal one, then the make backup is the one that you're using for making a rescue image, including the backup archives. And then you have some others, check layout. That's the function that is added in the cron to notice if something has been changed on the disk layout. New file system has been added, new version of your kernel, for example, stuff like that. And to recover is just rear recover. And all the rest is in fact some help. The format is to format your USB disk. And that's normally an extent 3 or extent 4 or something else, but not VFAT. That's not allowed. In practice, I already mentioned it more or less. So partitioning file system, bootloader, make a system backup, the tar or whatever, make it bootable, your rescue image, and it's done. It's normally quite fast. Mkrescue, var log rear, there it is the ISO image stored by default. If the output URL is mentioned, then it will also make a copy to the output URL. It's the NFS part, for example. The disk layout contains the information about your system, about the disk sizes, the disk layouts, the file systems, etc., etc. And if you boot from the rescue image, you can see if it recognizes all your device drivers, network drivers, very important if you want to restore from over the network, and also different drivers for your disks. If you do cloning, make sure if you're using not the same hardware, that at least the hardware that you drives that you need are also included in the rescue image. Otherwise, it will not be able to recognize to use it. And therefore, you can add in modules, for example, extra modules, because everything in rear is in fact a bash script. Even the configuration files are a bash script. So you can define it as an array, and you extend new drivers if they are required. Backup is as easy as mkrescue, but it takes a bit longer to make a backup, of course. Recovery in details, you boot from the rescue image, and then you just say rear recover, and it will recreate your disk layout, file systems, configure it, mount it, restore the data, make the bootloader active again, and then you can just, then it stops. You're still in the initial RAM disk. You can just inspect your system. You can change, you can look at the fstep file. Maybe not all unique IDs are modified. Normally, rear does it best to modify new unique IDs. But sometimes it's always handy to check most critical stuff if it's looking fine. And that's it. Then you reboot and you should have your system back. That's the how it looks to when you do a real recover. You have some options. If you restore your system and you reboot, maybe it comes back, but if you don't touch any key, it will automatically boot from the first disk. So if you forgot your ISO image in your system, it will by default try to reboot from your first disk. Otherwise, you have to select recover. There's also functionality automatically recover. Okay, some words about the simulation. If you want to start yourself, if you use an option -S, it will show you all the scripts it will execute, but it will not execute anything. It will tell you all the scripts it will find in the workflow, the make rescue workflow, make backup workflow, recover workflow, etc. Just to get acquainted in the different flows, and each flow have a configuration, preparation, layout, rescue, build, back, output, backup. Output is for the ISO image, backup is to make your backups effect. And the same thing for the recover, configuration, setup, verification, layout, preparation, restore, so restore your backup, finalize, and make your grub stuff, and then wrap up to copy your log files into your root home directory. So you always have the log file from the last recover. And, well, I think REAL is a great tool. I think because it's quite popular, I must say. And we get a lot of support with on our website, GitHub. Let's see if it wants to sell. This is the main web page. May I ask if you go to the Relax and Recover web page to take the survey, because the survey we will be using for future development. What are the most critical requirements of the people, and also how, if people are already using it, how they use it. It's for our own. We will publish it within a few months. We'll take some time to make it available on the internet, and then decide what the next development will be. And as a last word, if you have need of support or you want to search something about some questions, always check the GitHub, do a search, and then you'll find a lot of information, because we are already above the 500 cases. So most of the times answers are in there. If it's not there, we also have a mailing list. It's all in the support pages of our web pages. So please be advised to look first at the web, try it out. If you have problems, you get support. And if you want to develop something new, be my guest. Thank you very much. I think is there still any questions? If not, then it's time for the next speaker, I think.